The butterfly method is useful when adding and subtracting fractions. However, it has its limitations. Sometimes it may cause more work for us in the end in regards to reducing, and it requires that we multiply larger numbers than we would have had to otherwise. But first, let's take a look at what it means for two numbers to be relatively prime. This happens when the numbers have no common factors. Let's start here in example 0, and we're going to compare 12 and 45. 12 can be broken down into 4 times 3, and 4 further into 2 and 2. So 12 is 2 times 2 times 3. Do the same thing to 45, which can be broken down into 5 and 9, and then into 3 and 3. Notice that both of these factored trees have at least one 3, right? 12 and 45 are both divisible by 3. Thus, these numbers are not relatively prime. Do the same thing with 21, which is broken down into 3 and 7. 35 is broken down into 5 and 7. They have a common factor of 7. That is, 21 and 35 are both divisible by 7. Thus, again, these two numbers are not relatively prime. One more time, let's do 26, which can be broken down into 13 times 2, and 33, which is 3 times 11. Here we go. They have nothing in common. 13, 2, 3, and 11, no repeats. So 26 and 33 are relatively prime. Go ahead and pause the video and see if you can find which of the following 3 pairs of numbers are also relatively prime. If you said 4 and 15, you got it. Real quick, you can tell because 10 and 18 are both divisible by 2. 28 and 70 are both divisible by 7. However, 4 and 15 are not divisible by any of the same numbers. All right, let's actually add and subtract some fractions. So first here, we're going to use the butterfly method, but we are going to be dealing with relatively prime denominators. Looking at example 1, 4 and 7 are relatively prime. They have no common factors, but let's go ahead and run the butterfly method here. First, we're going to multiply 5 and 7. Oh, I want an oval. There we go. And then we will multiply 2 times 4. And then we will multiply 4 times 7. Good. This is going to give us 5 times 7, 35, plus 2 times 4 is 8. Over 4 times 7 is 21 for an answer of 43 over 21. And that's how it's done. That is the answer. Go ahead, pause the video, and do the exact same thing to the practice problem. If you got 17 over 40, that's it. Good. In the next example, we're going to use denominators that are not relatively prime. So, again, what does that mean? Well, look, at 20 and 15, those are both divisible by 5. They have a common factor of 5. So these two denominators are not relatively prime. And let's see what that's going to do. But anyways, go ahead and do the butterfly method. May need a calculator for this. Let's go 17 times 15, which is 255, minus 20 times 7 is 140, over 20 times 15 is 300, and this gives us 115 over 300. Now, 115 over 300, that is reducible by a factor of 5. You should always reduce when it's possible. And this gives us 23 over 60. So the butterfly method still got the job done. However, notice that we did not have to reduce in example 1, but here we did have to reduce. And that, again, that is because the denominators were not relatively prime. That is why we had to reduce. Go ahead and try the practice problem exactly like we did example 2. You should end up with 104 out of 60. And as promised, this is reducible. This reduces to 26 over 15. And again, I know it's not that much more work, but realize that this is one of the limitations of the butterfly method I'm trying to show you here, is that if you just go using the butterfly method whenever, you're probably going to end up having to reduce. You will have to reduce when dealing with denominators that are not relatively prime, right? Guaranteed that is something extra you will have to do. But let's go ahead and do the same exact problems from example 2. However, this time we're going to use an LCD. LCD stands for least common denominator. And when I say the least common denominator, I'm talking about the least common multiple of the denominators. So the least common multiple of 20 and 15 is 60. To turn 20 into a 60, you need to multiply by 3. Do the same thing to the top. To turn a 15 into a 60, you need to multiply by 4. Do the same thing to the top. And this is going to give us 51 over 60 minus 28 over 60, which is 23 over 60. And this should not be a surprise, right? This is the same answer that we got in example 2. But notice that this time we did not have to reduce. In example 2, we had to reduce. Here we did not. Now, that is not always going to be the case, as you'll see in the practice. However, I am making the argument that using the LCD is going to require a little bit less work in the end. Go ahead and use an LCD in the practice. It's the same problem you did before, but this time redo it using the LCD. The LCD is 30. And I'm going to go ahead and do this with you. Hopefully you tried it on your own. We need to multiply by 5 on the first fraction to get the 30. We need to multiply by 3 on the second fraction. And this is going to give us 25 over 30 plus 27 over 30, which is 52 over 30. Now reduce. 52 and 30 are both divisible by 2, and this gives us 26 over 15, which is the answer we had before. So, good. Notice here that yes, we still had to reduce. We just didn't have to reduce as much. Last time we had to reduce by 4. This time we only had to reduce by 2. So, let me state what just happened concisely. If you are dealing with fractions whose denominators are not relatively prime, and you use the butterfly method, you will have to reduce, guaranteed. However, if you use an LCD, you may end up not having to reduce at all, but if you do, you won't have to reduce by as much. So, yes, it takes a little bit more thinking up front because you have to find the LCD. However, it saves you reduction in the end. Let's go ahead and discuss the pros and cons of the butterfly method. The pros: it requires no understanding of how fraction, addition, or subtraction actually works, right? You could be given a fraction, a problem for the first time ever and just say, hey, multiply the diagonals, multiply the denominators, there's your answer. And you have no understanding of why it worked, but you could get it done anyways. And then it can also be done without any knowledge of a least common denominator. Again, in example 2, we got example 1 and example 2 without using an LCD. We didn't even know what the LCD was in example 2. We didn't need it, right? The butterfly method got the job done. The cons: It results in a reducible answer when the denominators are not relatively prime. Guaranteed, you will always have to reduce if the denominators are not relatively prime, but you may not consider that a big deal. I'm going to stick by point 2 here as the strongest con for the butterfly method, is that it requires the unnecessary multiplication of larger numbers. So in example 2, remember, we had to multiply 17 and 15, right? Most people can't do that in their heads. I myself needed to use a calculator for that. Now, when we used the LCD, we didn't get numbers that were nearly as big as 255, 140, or 300. The largest number we had to deal with in example 3 was 60. And I would argue that this is a huge benefit of using the LCD and a big limitation of the butterfly method, right? Overall, it would be nicer to not have to deal with large numbers. And then the third con here says that it cannot be used when adding or subtracting more than 2 fractions. So say you wanted to add 1/2 plus 2/3 plus 3/5. You could get this done using the butterfly method, but you would have to do it twice. However, if you use an LCD, you could get it done in one pass of using an LCD. So good, of course, you're entitled to your own opinion. If you like the butterfly method, it'll get the job done. But the LCD, you can avoid having to reduce as much, and you can avoid the larger numbers if that is what you prefer. But anyways, thank you for watching. Please like and subscribe. You can find a PDF of this document in the description below.